Okay, so 8th period, I'm going to give you some instructions so that you know what to do for homework, and so that you have the same number of pages done with you that the other classes have. So remember when you left, we were talking about Rebecca, who was doing cross-country cycling and was going about 10 miles per hour. So we had shown on our screen how that went up the number line, and then you were filling out your table when you left. And we were talking about the rule. Remember we said that the rule, to be true, has to be true all the way down. It can't be just good for one, it has to be good for all the way down. And we can say 0 times 10 also, because we know 0 times 10 is 0. So remember that when we started building equations, when we started building ratio tables, we had letters that mean a label, like hours is represented with an H. Miles is represented by an R because this is specifically Rebecca's miles. They do that because we're now dealing with two different people, and to keep it straight, we want to make sure that we understand Rebecca separate from Daryl. If we were to look at, so let's finish off our rule. If we were to look at our table from hours to Rebecca's miles, our rule is times 10. But if we were looking at miles that Rebecca cycled to hours, how would our rule change? Well, we wouldn't want to say 40 times 10 is 4 because that wouldn't make sense. So our rule would change. 10 would stay the same, but our multiplication would turn to division. And you should remember that from 4th and 5th grade table reading. Then we're looking at Daryl, and our story said that Daryl goes about 8 miles per hour, so he's a little bit slower. For 0 hours, of course, he goes 0 miles. We said for 1 hour he went 8 miles, 2 hours, 16, and we built our table from there. Now you have to look at the process, and the process, remember, is saying how did we get from one to the other? What's our rule? What's going to be here that is all this true for the same? So if we have 0 hours, 0 miles, that doesn't help. 1 hour and 8 hours, what do I do to 1 to get to 8? I can times 8. But it has to be the same for all the way down. 2 times 8 must be 16. It is. 3 times 8 is 24, that's correct. 4 times 8 is 32, correct. And we just want to make sure that it's the true all the way down, because I've seen one that is addition, but it looks like multiplication at first glance if I just were to do the first numbers. And so that may come up as an addition problem that looks like multiplication until you look at the following numbers. So just be careful and make sure you're reading your table. Again, if I were reading it from hours to Daryl's distance, it would be times 8. If I were looking from Daryl's distance to hours, that would change to a divide by 8. So using this information for our tables, we're going to answer some questions. A says, how long does it take Rebecca to finish the 40-mile course? So I'm looking at Rebecca specifically and 40-mile course. So I'm looking at my table, 40 miles, how long? 4 hours. Two is how long does it take Daryl? So we're looking now at Daryl for 40 mile. So now I'm going to look at Daryl's table, look for miles, 40, go over to how long, that would be hours. So it took him 5 hours. Now C is asking for use the process column, so the column in the middle, to write a sentence and a function rule. A function rule is the same as an equation describing the relationship between Rebecca's distance and the elapsed time, meaning the hour. So this is Rebecca's distance and your hour. So remember when we were doing building ratio tables, how we were constructing an equation. it was not specific to any one number. It was just saying, how do I link hours and miles in an equation? Well, you have to think, what's my rule times my hours would equal Rebecca's miles. But I can write that in a little bit more of an algebraic term. We can put 10 H equals R, because remember, side by side means multiply. So you try with Daryl's. Same thing, function rule, but now we're looking at Daryl's distance from the beginning of the course. Elapsed time is the hour. Pause the video, try it on your own, just to see if you got the correct equation. Okay, hopefully you pause it so you can just check yourself. So I could do the same thing. I can do 8 because my rule changed from Rebecca to Daryl. So now I'm going to do 8, but I can use the same idea as I did with Rebecca. 8 times H, meaning hours, equals Daryl's distance. And I want to write it a little bit more friendly because I know side by side we multiply. So if we wanted to check and make sure that this equation makes sense, we could put a number in. So if I looked at Daryl's, I could say, okay, 8 hours. What's a good number for hours? Well, I can pick any one of these. So if I said, okay, what if I want to find the distance for 2 hours? 8 times 2 is 16. 2 times 8 is 16. It matches. What if I wanted to show how long or how far he was in 5 hours? We replace the hours with a 5. 8 times 5 is 40. 5 times 8 is 40, and it matches. So you can always try your equation to make sure it makes sense by adding numbers. And I just pulled the numbers off of the table. Okay, second page. This should look familiar to you from last year with coordinate pairs. It says label the axis, plot the points from both tables, and label each point with an ordered pair. So when they say point and ordered pair, what we're looking at is X and Y. You all probably have a saying to remember which one is first. We used last year, crawl before you walk. All that reminds us is it's X. X goes this way, horizontal. Walk, Y goes up, vertical. So that saying is just reminding you to, when you have an ordered pair, to go this way first and up second. So look at our numbers, 1, 2, 3, 4, 5. You have to think, on my table, what did that match? Well, that matched my hours. While 10, 20, 30, 40 matched what? Miles. So I'm going to label those so that I know what I'm talking about. So they asked us to plot the points. So let's start with Rebecca. When Rebecca went 1 hour, she was at 10 miles. 2 hours, 20 miles. 3 hours, 30 miles. 4 hours, 40 miles, and she was done. So we're just going to connect the dots essentially with the origin where our zero's at. And I'm just going to label, this is Rebecca. Then I'm going to do Daryl, same thing. If he went 1 hour, he had gone 5, 6, 7, 8 miles. 2 hours, 16 miles. 3 hours, 24. 4 hours, 32. Just do your best. They're not right on a line like Rebecca's is nice and neat. And then if he went 5 hours, he was finished. Again, start from the origin. Just kind of line them up. Connect the dots. And label this is Daryl. And you have to notice the lower the line, meaning it's under, the slower his rate is. Okay, so now we have some questions based on this information. A says, what does the ordered pair, well, as soon as you see ordered pair 3, 30, you know that what this means is the 3 is X, the 30 is Y. So if I look at 3 and 30, that's on whose line? Rebecca. So we know we're talking about Rebecca. And what do those numbers mean? Well, 3 represents hours, so 3 hours. The 30 is the 30 miles. So in 3 hours, she was able to go 30 miles. B says, how does the point 330, which we just looked at, we know that this is Rebecca, compare with the point 324? Well, let's look at 3. Go to 24. That's on whose line? Daryl. So this is Daryl's information here. If we're comparing, we're just making a statement. It can be that they are 6 miles apart. We could say Rebecca is 6 miles ahead. We could say Daryl is 6 miles behind. Any statement that just compares the two so that you're reading your graph accurately. Okay, C says, what does the ordered pair 2.5, 20 mean on this graph? Okay, so we have to look. Where would 2.5 fall? Look at your graph. I have a 1, 2, 3, 4, 5. No point 2.5. The 2.5, remember, means 2.5, so it's right in between 2 and 3. Follow it up to 20. Well, we don't have a dot there, but there is a line there, and whose line is that? That would be Daryl's information. And what this you should be able to read from this is if he went 2.5 hours, he was able to go 20 miles. D says, how long did it take Rebecca to travel 20 miles? Okay, so let's go back up to Rebecca. Here's our 20 miles, Rebecca's line. Follow it down. How long did it take? Well, for her, 20 miles is equivalent, or took, 2 hours. Okay, so that's your reminder on how to read the ordered pairs and how to plot them on a graph. Okay, turn the page. If you are using color, go ahead and switch to pencil because this is the part that you're going to be responsible for. But we're going to go ahead and just set up the table really quickly. For every single batch of cookies that Mona bakes, she uses 4 cups of flour and 2 eggs. So even though 4 to 2 are not our smallest numbers, we don't want to get a base because it says for every single batch. Well, that's one batch of cookies. If I find a base, I'm looking at making half a batch. Nobody wants a half a batch of cookies. We want a full batch of cookies. So we have 4 cups of flour, 2 eggs. Now on this table, I want you to think both sides. Let's first look at our cups of flour and what the relationship to the eggs are. We're going to ask ourselves, what do I do to 4 to get 2? The first thing we would think is, oh, we're going to divide by 2. But we're going to practice our 7th grade skill of finding a scale factor. And remember, our scale factor is multiplication only. So it's not dividing by 2, but rather multiplying by 1/2. We just want to try to get used to that term of multiplying by fractions. So 6 would have to be multiplying by 1/2, because remember the process or the rule, if it's good for one, it has to be good for all. 8 times 1/2, 12 times 1/2. But if I'm going, so we've got a blank number here, that'll be times 1/2, so x times 1/2. If we were going the other direction, if we were looking at eggs to flour, what do I do to 2 to get 4? This would be times 2. Whatever number goes here would be times 2. So what times 2 is 6? 3. This number times 2, well, what times 2 gives me 8? 4. This number times 2, what times 2 gives me 12? 6. And then this one will be times 2 once I know what number it is, so we could say y times 2 gives us x. So our process is dependent upon whichever one. These are opposite of each other because this is like dividing. So we've got our process and we've got it set up so that we are able to answer any question. Okay, so your homework, now that you're caught up with the other classes, your homework is to answer the questions for the table that we've set up. Just be careful to look at which direction are they asking me to go. And if you turn it on the back, there are not many questions, but what I want you to focus on is how do you fill out this table in its entirety? And then they give you a graph that you can put coordinates on. So you'll notice we have an X that stands for pizzas, so your players will probably be Y, and the reason they're not doing P or PI or PL, the reason they're choosing X and Y is because you're going to put it on a graph. And so that way you know X means I crawl, Y means I walk.